All right, now that it's up and running, let's connect it to the system. To do that, I'm going to run the wire, and once it's ready, I will disconnect the battery, the old battery, connect the new bank up, and have a little celebration. It won't be anything big, but I'll probably be a little happy. I mean, I'm already a little happy. Okay, I hope that wasn't too loud for the mic. Anyways, let's run this big long wire. All right. The first thing I'm going to do is put ring terminals onto these so I can actually anchor it and hold it in place when I run it around. When I have the length sorted out, I'll disconnect that, crimp and connect that side, and then come back and reconnect this. At least that's my plan, subject to change. Obviously this run is going to be so long that I don't particularly care about the alignment of the two ends. One thing I was thinking about / worried about when I was considering making this big long run is that it's going to use up a decent amount of my marine grade wire. And I was thinking maybe I should just go get some cheaper wire. But this is going to be long enough. I am sure I'm going to be able to reuse most of it when I actually get to the boat refit, repower. I've more or less decided that I want to get an electric windlass, which is the doohickey on the bow of the boat that you use for lifting and raising. Lifting and raising are the same thing. Lifting and dropping the anchor. Being solo, I'm not going to have somebody to drop the anchor while I'm at the helm so I can back up and set it. Having an electric one strikes me as a very important single-hander tool, and this 4-gauge would probably be perfectly fine considering I'd get a 48-volt windlass. Okay, that's done. So this wire, the reason I mention that right now is this wire is probably going to be long enough to get to the bow. If not to the bow, I can definitely get it part way if I want to have some 48-volt drops in the main saloon and then carry on from there to the V-berth area. Wow, I did not cut this straight at all. You think after doing this many I would have had that dialed in by now, but nope. I need progressives. That makes me feel old. Oh wait, because I am old. Damn how that works. Oh well, the older you get, the more fun your toys. Why am I struggling so much? Come on, I've done this 100 times. Literally. Over 100 times. There we go. Let me reposition you so you can see how I'm doing this. At least how I think I'm going to do this. I'm figuring this out as I go. All right, bit of an odd camera angle, but it's just what I have to work with. Cat hair everywhere, cat hair. I don't know if you can see it off camera, but what I'm doing is as I pull it, I'm slowly just loosely putting it around the wall. Try to get it roughly the right size, right length. Another 6 feet roughly, 2 meters. I forgot how heavy this thing was. Cat hair everywhere. So annoying. I love my kitties, but god darn, that's annoying. All right, short by about 1 meter. How's this? That'll reach. That'll do. It's not an ideal or clean setup, but it'll work for my purposes. So now I can go and crimp the far sides. So I want to be able to push that back and come up into here. So let's say we get to about here. That should do. Those are significantly lighter. I pulled the other end off the bus bars, but even if I hadn't, it wouldn't matter because all the batteries are off currently. Oh shit, that's cutting it closer than I thought. Ooh. Okay, it'll reach the bottom post. Whew. I really should have given that an extra 1/2 meter. Oh well, too late now. That's going to be the last time I use that for a while, hopefully. I should mention, I tried to find these covers for the larger bus bars, but Blue Sea doesn't seem to make them. I will use the ring terminals that the SmartShunt is using. Is that a 10? Okay, that just sparked. Why did that spark? I think it's time to shut this down. All right, less sparks this time, hopefully. the negative done, let's do the positive. Right, let's connect the other side now. There we go. The two bus bars are connected. I'm going to pull the SmartShunt out of here. I'm not going to have a SmartShunt per battery anymore. What I'm going to do is put the SmartShunt on the negative cable. So I'm going to take it out and mount it below the negative bus bar, jump to it, and then jump from there up to the bus bar. This looks awkward. It also feels awkward. I'm going to break this up into the 12 volt banks. I haven't decided yet whether I'm going to do 2P or 1P. If I do 2P, that's 14 kilowatts on the 12 volt bus, which is kind of insane. I don't know if I'd be able to find a place to put them all in my boat. Well, I could do them as 2P for now, and then... Oh, it's been a while since I've looked in here. Ow. That battery's been running for 296 days, 9 hours, 31 minutes, and 41 seconds. Oh, this project's taken a lot longer than I expected, which I suppose itself I should have expected. Got it. Hello, cat. Are you a cat? Actually, I'm curious. What does the BMS say the voltage is? BMS says it's 53.29 volts. 53.39, 53.29. So the meter and the BMS are disagreeing by 0.1 of a volt. I think I would trust the BK Precision more, so yeah. Not entirely sure I trust the voltage on these things very well. I will set this up now on the main bus. I'm going to drop this down to make space for this to sit in here. Why did past me use such long screws? Is that enough space? Yep, that's enough space. Now, the irony of ironies. That's the wrong terminal to connect to here. I can probably cut this. Well, I really don't have a lot of slack. I'd like to use this and just swing it onto here. Recap that here. I think I can do it. Yeah, I've got a bit of slack in there. That's what I'll do. This desk, I know you usually see it in the background covered in crap, but it was my second big project I did with my woodworking teacher. Hard maple with purple heart inlay. He stopped over yesterday, and I was a little bit nervous if he saw me with all the crap on here that you've been seeing in the videos. And he saw it, and he looked at it, he looks at me and he goes, "That makes me really happy." It was really nice to know, ooh, I almost crimped on the wrong end. It was nice to know that he was happy that it was all being used as a proper desk and not just being kept as a piece of furniture. I'm gonna have to change this from a battery that is 280 amp hours to a battery that is 1,680 amp hour battery. I'm sure this supports it. It's Victron after all. That's a hell of a jump up. And the SmartShunt's connected. We should be ready to fire things up again. Everything's ready. Shall we power it on? I think we shall. Ah, the nerves hit at the weirdest times. What am I waiting for? Let's do this. Step 1, boot all the BMSs. Okay. Oh, interesting. Yesterday when I did my first start, BMS A was showing 33% and all the others came up at 66%. For some reason, today it's all showing 66%. I just don't think it's calibrated. 52.27, 52.15. I really don't trust these voltages very much. However, there they are. So there's all of our BMSs. Let's use the first one as an example. It's saying 52.27 on this screen. What is it showing in the app? 52.27. Okay, so the value it's seeing on the screen is the same as the app. That's good at least. What about BMS B? Is it the same? 52.15? Looks like I crashed the app. Wouldn't be the first time. $52.15. Okay. That went to 52.14. That 52. No, they're not the same. They're off by 1/10 of a volt. So this must have its own voltmeter in it. Well, this one here is saying 52.43. That's a pretty big deviation. Don't tell me it's going to crash the app every single time I switch between BMSs. I'm just going to wait for a second to see if it eventually connects. Yeah, looks like the app crashes every time I try to switch BMSs. Good Lord, JK. Good Lord, JK. 52.43. Now, let me put you on the tripod. I know it's going to be hard for you to see there, but I want to see if the voltage at the main pack positive differs. So this one is listing 52.27, 52.45. That is off by almost 0.2 of a volt. 52.15 versus 52.47. These voltages are way off, like not even close. All right, I mean, it's saying 52.43. This one's probably actually going to be the only one that's close. 52.45. This one is right. Wrong. Wrong. 52.65 on the last one. That seems high. Let's see. And all the batteries are disconnected from the bus, so I'm reading the voltage coming off the individual battery. 52.40. These are all way off voltage compared to what the JKBMS is reporting. All right, whatever. It's hard to get more disappointed with them. Wow, what a disappointment. Okay, first one, we'll light up the inverter, so we should hear a chunk. All right, I'm not seeing anything from the inverter yet. Servo GX is not up yet. Nothing is powered up yet. What is my voltage at the bus? I have no voltage. Oh, are the outputs off? No, the BMS is off. Why is the BMS off? Discharge short circuit. Discharge short circuit? Okay, I'm disconnecting this again. Do I have a short between my positive and negative? Holy fuck, I do. Wow, okay, so I badly screwed something up. Okay, well, right after bitching about them, they apparently just saved me. Where the hell do I have a short circuit? Whoa, something just blew up. Something just blew up. Yep, I can smell something. I don't know what it is, but something blew up. Wow, okay. What did I just blow up? I blew up my buck converter. Okay, that's, of all the things to blow up, that's not the worst. Okay, let me verify if I still have a short. Yes, I still have a short. And those are all disconnected. So that probably blew up because of whatever shorted. I need to figure out what's going on here. What the hell did I do wrong? Nothing like the smell of fried electronics. All right, let's see if I still measure the short circuit over here. No. What? How do I not have a short circuit over here? Oh, I do have a short circuit over here. Okay. Okay, so it's somewhere over here that I have a short circuit. That's disconnected, so it's definitely not these wires. This is not how I thought things were going to go right now. Fuck. The short circuit was through the power going to the SmartShunt. Did I damage the SmartShunt? 2 battery minus. Why is this creating a short? And if this was a short circuit, why did it not pop the fuse? Okay, before I get too much more accusatory, let's put this back together and see if the short circuit is gone. Right now, there's no short circuit, right? There was a very brief one, but that was probably just the capacitors charging up. Yep, no short circuit. My short's back. The fuck is going on here? Oh, this is not how I expected my day to go. I'm completely disconnecting the charger. All right, do I still measure a short? I do. I remember running into this last time when I was working with a transformer, because obviously the coil would be a short, but why would there be a short between the battery positive and the battery negative? That makes no sense.
Hello.
Hello. I blew something up.
Uh-oh, what happened?
I don't know. When I powered up the first BMS, everything looked fine. When I turned the main disconnect switch on, nothing happened. So I went to the BMS and it said it was over overcurrent protection and the output was off. So I came over to look
A
at,
short circuit somewhere?
well, that's what it seems like. So this wire goes out to the new bus bars. The remote bus comes to here, and then from here to this bus, and then from this bus it goes to the solar panel and the inverter charger and whatnot.
Uh-huh.
Basically as it was before. While I was looking at this, trying to see if I made a mistake somewhere, I heard a pop and I could smell the smoke. So all of the new batteries are completely disconnected, but I'm getting a dead short on the Victron Quattro, which makes no sense to me whatsoever. I've got it on continuity.
The black and red wires there are shorted?
Seem to
Where
be.
did the pop, where did the noise come from?
One of my buck converters blew up.
Oh, really?
Yeah,
What?
I know.
They take up to 90 volts.
The smoke trail seems to be near the capacitors. I haven't really looked at it much because I just pulled everything off. Then I thought maybe it was this, which is the 5-volt supply, or sorry, 48-volt supply for the SmartShunt.
Okay.
And when I pulled it out, I got no short anymore.
Whoa. Weird.
And then the short came back. Like, none of this makes any sense whatsoever.
I don't know the full setup there. So measure across. Those are not going anywhere, right?
That's these ones right here. So the inverter,
That's the only thing that's connected to those?
well, the AC circuits are there, but
No, but I mean to those terminals, those two terminals there.
yeah, that's it. Just those two.
And you still measure a short across there?
And I still measure a short across here.
No, but that may not be a short. That might just be like a really low impedance of something.
Should I check for resistance?
Yeah.
0.0 ohms.
Whoa, weird. Huh. And that's just DC in, is that the idea?
That's DC out. Well, DC out in, depending on whether it's inverting or charging.
Oh, I see. So did you break it?
I don't know how I did, if I did. I mean, literally, I climbed under here, turned off the main disconnect of the old battery,
Okay.
ran the new wires. I pulled the SmartShunt out and put it in line with the negative out to the new battery bank. Oh, fuck, I forgot to
Measuring
put this in.
resistance in a high power circuit is not always going to give you reasonable readings, because there could be enormous capacitors across there that take ages to charge up.
Camera batteries died.
Did something burn up?
Yeah, something burned up. Let me go show you what it is. If that was just charging up the capacitors, why would it have blown up my buck converter?
Now, did you put diodes in series with the input, right?
Yes, I did exactly as you suggested.
Very odd.
It is very odd. That's why I had to call you. I sat here and I've spent like 10 or 15 minutes trying to figure out for myself what the hell I did wrong, and I can't figure it out.
This is why I spent weeks and weeks in Spice doing simulations, because you can blow stuff up in there and it's free.
Fortunately, I don't have that luxury.
And you can also measure things that would be difficult to measure in real life without causing a fire.
I'm disconnecting the burned out buck converter.
Is this the first time you've powered it up with 48 volts?
No, these are all powered up with 48 volts. All of them. And they were all working. This was working until I switched this main switch on, and then it blew.
Weird.
But it didn't blow right away.
Some sort of surge or something that went way over the voltage.
Well, the thing is it didn't blow up right away. I was sitting there looking at the inverter charger, and it was probably 30 seconds to a minute later that I suddenly heard a pop.
Now, did the screen come on?
The screen was on until it popped. Now, actually, here's one thing. The screen turned off for a little bit and then came back on before it blew.
You've got a diode in series with the input, so it wouldn't have reverse biased.
The positive.
It's short circuit protected in the circuit, so I don't know why it failed.
Well,
I'm sure it was
the skid mark.
The capacitor or something.
Yeah, so the skid mark is by the capacitor.
Oh, okay, that's different. Show me up close. So the capacitor blew out?
I don't know if the capacitor blew out. There's a little bit.
What does it smell like?
Doesn't smell like much now.
Does it smell like carbon, or does it smell like weird pungent odor?
I can't smell anything.
And whoa, look, it grew.
Yeah, it did. Did I have a capacitor failure, or is that overvolting it?
What's the rating of the capacitor?
K.
No, you have to look at the bag. It won't have enough information on there. Either it's reverse polarity or it's over voltage. Those are really the only two options for a new capacitor like that. And it would have shorted out, which is why your screen would have gone off. Because all the energy going in there is what caused it to grow, because the electrolyte gassed out and created pressure inside. Like it deformed the metal. There's serious pressure in there, right?
That's probably the bang I heard then, was the canister
The pressure
failing.
relief.
It was very depressing. I thought I was about to turn it on, show everything was working, finish the video, and relax. And yeah.
Don't worry about it. This makes it more exciting.
It's frustrating though.
Don't give up. Don't give up on electronics when you blow stuff up.
Come on, dude. You know me. I'm more than stubborn.
Yeah.
I'm not going to give up on shit. But I will be depressed, but I won't give up.
So where's the capacitor in relation to the diode?
Parallel.
Parallel? The capacitor is connected to the input, not after the diode. No,
This
the
is where
capacitor needs to be after the diode. The original sketch you made for me was correct, because I checked it before. You had made a little schematic. In this situation...
I see the difference. 1 second. I'm bringing this around so I can cop my shame on the video.
Let's diagnose this. Think about what happened in your situation where you've got the capacitor before the diode. The capacitor in this case is not protected against reverse voltage at all. So if there was a negative spike on the line when you hooked up the load, there may have been like a bump where it went down. If the capacitor saw reverse voltage for any amount of time, you're basically a game over.
And that would explain why this blew up.
So let's say there's a dead short on the other side, or it drags the BMS down so far that it decides to do an overcurrent trip. What happens when it removes itself from the load? Now, this is on the battery side or on the output side? It's on the battery side.
It's on the battery side, yeah. That goes to the main pack positive, and that goes to the negative after the BMS.
So, let's say the BMS... So this is even on even if the BMS is off, or no?
No, if the BMS goes off, the negative opens up and there's no circuit anymore.
And what else is connected to that negative? Is that connected to your output also?
Yeah, so this is the output of the BMS going to the Anderson connector, and then the Anderson connector goes up to the main bus negative. The negative terminal was here.
So it's possible that negative side could have been lifted up to the positive supply on your other side, and then you would have a reverse polarity situation going on.
How would the BMS allow that to happen, though?
Well, it disconnects its negative side, and then the other side's floating.
Oh.
So now you've got your screen connected to a floating connection, and the positive's still connected inside your circuit, but the negative's floating, and now the negative's running all the way through your inverter and then back again. Like, who knows? Like, there's a bunch of capacitors in there that partially charged up, and if they're going to dump their charge back, you could easily have ended up with the reverse polarity on your screen capacitor there. That's what that diode's for, right?
And because I changed the design, not realizing the implication, I thought so long as the capacitor spanned the positive and the negative of the input, it would do its job.
You have to assume when you disconnect large loads like this, there's all kinds of inductance built up in cables and stuff. You're dealing with big currents, right?
Yes.
If you disconnect something and now it's floating, you've got inductance. It has to go somewhere. Where does it go? It goes into back EMF. It's going to kick back in the negative direction.
So this negative lead would have gone to a much higher voltage potential.
And now it's reverse polarity in respect to your capacitor there.
And that's what blew that up.
The capacitor can't take any reverse voltage at all. The only reason why the voltage spikes up is because there's no current flowing, and they want some current to flow. So the voltage will keep spiking until some current flows. So the trick to getting around that is that you want to have a place for it to go. So what you do is you use like a Zener diode or some reverse bias diode, and you provide a path for its current to discharge safely. Like, it's called a snubber, and this happens in all kinds of inductive circuits. If you don't provide a path for the voltage, for the current to flow, the voltage can end up with extreme, like thousands and thousands of volts. That's what happens.
Yeah, okay. This is similar to how if you disconnected the BMSs with the alternator pumping power, you'd burn up your alternator.
Same thing. It's got inductance in it, and it's charged up, and there's current flowing, and all of a sudden you open up the circuit, and there's all sorts of energy built up in the magnetism in there. That Victron probably has big inductors in its input to prevent noise from coming out through there and going back into the DC cables. This kind of snubbing and filtering when you're dumping a load, things can happen, and you can end up with a reverse polarity spike. And if your circuitry isn't ready to handle that, that's what caused that capacitor to fail, no doubt. And nothing ever goes down to zero and flatline. That's not how it goes.
Yeah.
There's energy that's dissipating.
Yeah.
Like, even a voltage spike on a digital signal has ringing.
Yeah.
Because there's inductance in there, right? Nothing is like, It's like, below ground, overshooting a little bit. And that's what you have to protect your circuitry from.
The takeaway is, I've got the diode in the wrong place, or rather, I've got the capacitor in the wrong place relative to the diode.
Mm-hmm.
I didn't use a pre-charge resistor. I didn't think I was going to need it. I do, and that was what was triggering the overcurrent.
Yes.
The capacitor was smoked by the BMS cutting off the power, causing a big back EMF.
Back EMF pulse, I'm sure of it, yeah.
Yeah, and
I think what probably happened, you said the screen came on and went off and came back on again.
Yes.
So what I think probably happened is that it partially failed when it went below ground.
Yeah.
It caused some of the electrolyte to break down, and then when the voltage went almost back up to its limit,
it came back alive.
Working voltage. Now it's already broken down a little bit inside.
Yeah.
Now it starts to get hot, and over the next minute or so,
which would be why I saw 30 seconds to a minute before I heard the pop.
It's overheating.
Yep.
Now some pressure's building up.
Because I'm boiling the electrolyte.
The electrolyte's starting to boil and get hot, and gas is building up in there, and all of a sudden,
pop! All right, so I need to then figure out if there is a way for me to save the boards that I've built.
And just move the wire.
Yeah.
Move the wire from your capacitor to the other side. That's all you need to do.
Failure is always an option. I failed. That's okay. I can fix it, but
at least
I need to get into the
one capacitor. That's like no big deal.
I think the main thing that scared me was when I saw the dead short on the Victron Quattro. I'm like, that's $4,000.
No. I'm sure.
I know. I know now it's okay, but I was sitting here looking at all this equipment that I have spent so fucking much money on, and I'm like, what did I just destroy? Thank you.
This is all part of the learning experience. Don't get yourself down about
it. Oh, I am down, but I know I won't stay down.
Well, I feel better that my circuit wasn't bad.
No, I fucked it up, and that's good, because...
Yeah.
All right. Thanks very much. Bye-bye. I should have validated that circuit with Andrew before I tried to do this. I thought I was going to be done tonight. You know what? I might still end this video here, and then on the next video, I'll connect everything. But let's first verify the Quattro's okay. All right, now you can see. Back when I had just one battery, it was really easy to know where to put the pre-charge resistor across the main switch. Now that I've got 6 batteries, I could put it on one and say, okay, always start with this one, but what if that's the battery that fails? So I need to think about where I'm going to put that'll all be in the next video because I need some time to think. I think that was the first time I ever tried to connect a battery without using a pre-charge resistor. Okay, that's off. I'm going to flip that to on. Pre-charge resistor for 5 seconds. 1, 2, 3, 4, 5. Main connect. Protection discharge short circuit. Nope. Still getting a short circuit. I don't know what's going on. What the hell am I doing wrong? Simplify. Time to simplify. I am going to run the battery straight into here and everything else disconnected. Oh, you can't even see a fucking thing I'm filming. Things are not going well. I thought I could run this straight into here, but these are different size lugs. I can't. I have to go through the bus bar, which means I have to strip the bus bars down, except for going from the old battery directly to this, nothing else on it. Thought things were going too smoothly lately. So the old battery is connected to the bus bar and nothing else. Everything else has been stripped off. The only other connections are the ones going into the Quattro. You don't get any simpler than this. These go to the breakers, but the breakers are off. This goes to the mains, but the mains is unplugged. Okay, I'm gonna leave this in the off position, and I'm gonna see if I get an overcurrent again. Sorry for the shaky cam. The first thing I want to do is verify that when I press the pre-charge resistor, I get 50 something volts on the Anderson connector. 53 volts. Let go. Okay, so the pre-charge resistor is working. Not how I thought the day was going to be going. Oh well, like Andrew said, don't give up. I hope that's focused. 1, 2, 3, 4, 5. On. No overcurrent. No overcurrent, that's good. So if I check across here right now, I should see 53 volts. Okay, let's see what happens when I turn this on. It's fine. It's fine. All right. Turning the battery off. I should have no voltage now. I still have 52, 51. Oh, the capacitors are draining out. All right. I am going to connect the new battery directly to the bus, bypassing the SmartShunt, and see if I can start it. Hey, Tatters. All right, that now connects the other bus bars. I don't have a pre-charge resistor on. If I use that pre-charge resistor on the old battery, and then I turn this on, that should be high enough voltage, judging by how low it's, or how slowly it's dropping. So let's connect this. Actually, no, let me get the app first. So right now, this should actually have the same voltage as the inverter. Yes, it's 24.4 volt. If I press and hold the pre-charge resistor for 5, this should now be back up to 50 some volt, 48 volts. Okay. Okay, let's turn this on before the pre-charge resistor is dropped out. It hasn't popped yet. Oh, I was pointing at the wrong one. Sorry, being a little flustered, I'm not doing the best recording. Okay, this is now being powered by the first battery. It's showing low battery. That's not a huge surprise. So that's fine. So let's turn this off. Let's add the SmartShunt back in and see if that was the source of the problem. Turning battery A off. Another day where it's 11 o'clock and I've only had half a drink. The VE Direct is off. So the only thing right now is the negative is going through the shunt, nothing else. 39 volts, okay. Use a pre-charge resistor to bump this back up to 50 something volts. And then I will turn on the other battery. 5, contact. I'm not seeing an overcurrent message. Now I should have a stable 50 some volts. 52.45 and holding. On. No overcurrent message. No overcurrent message. It's fine. It's on. I got the low battery alarm, but again, I don't care about that. Okay. Turning this back off. BMSA is off. I should see the voltage dropping here now. Yes, the voltage is dropping. Okay, so the only thing I'm going to do now is apply power to the SmartShunt. Oh! Okay, I just saw a spark. Why did I see a spark there? VBAT plus. Why did that spark? Okay, it sparks when it gets power, I guess. I guess it makes sense that that would have a capacitor in there as well. All right, let me bring up the Bluetooth app. Connecting, firmware update. All right, let's update it. The air light's blinking, that's probably just because of the firmware upgrade. Firmware updated to 2.41. Okay, connect. So it sees the voltage at 28.7. Well, that's nice because now it means when I hit the SmartShunt, or when I hit the pre-charge resistor, I can see the voltage on the bus come up. 5. Interesting, it took almost 10 seconds to fully charge it. Okay, main contact on the main battery. Now, I have no short. No short yet. Let's turn this on. Inverter on. Wow, it's seeing 8 amps, or 0.8 amps coming out of the battery. 42 watts it's drawing right now. Okay, so that's fine. Let's add the Servo GX next. Oh, whoops, I put the negative on the positive. I am not in the clearest head right now. Maybe I should stop. Maybe I should do a lot of things I'm not going to do. Sparked again, but I guess that should be expected. Is the battery still on? Oh shit, I left the battery on. Okay, Servo's alive. So that's fine. Still no short. The only things really missing at this point are the solar panels. Was it just the pre-charge resistor? For whatever reason, that time I tried it, Maybe I just have to hold the pre-charge resistors longer. I think when I set up on the boat, what I'll do is I will have a voltmeter somewhere so I can actually see the voltage on the bus, and I can hold the pre-charge resistor until I see it hit 50-ish volts. Solar panels are now connected. That puts the system completely back together. All right, how should I do this? The pre-charge resistor, now that there's a bunch of load on it, when I let go of the pre-charge resistor, the voltage drops really fast. Faster than I can probably run over. I think I should switch. I'm gonna kill the BMS app and switch back to the old BMS. If I hold the pre-charge resistor, enough power should come through to boot the SmartShunt, and there it is, it booted right away. And it sees the MPPT solars now. Okay, so I know there's voltage on the bus, so while I'm still holding the pre-charge resistor, turning on the old battery, 53.3 volts and holding. I'm going to turn this battery off, and as quickly as I can, I'm going to run over to this battery and turn it on and see if I can get the new battery running. Off. On. Voltage is stable at 52.36. We don't have an overcharge condition. An overcurrent condition. Okay, I think I'm going to call it here for this video. I wanted to end this on a high note, but c'est la vie, c'est la guerre. At least I know nothing's blown up yet, except for my buck converter, but that's not a big deal. It looks like everything's living again. I want the solar coming into this tomorrow. Oh, wait a second. I'm not done yet. I didn't turn the inverter back on. Let's just make sure that the inverter's still working. Okay, we're all right. I want to get some solar into these. I think, yeah, I'm going to end this here. Off camera, I'm going to pull all the buck converters out and start coming up with a plan to fix it. I know Andrew was saying you could probably fix it in situ, but I want to set up on my desk. He's right, I'm sure I could do it here, but he's also got decades of experience and I'm new, so I think I'd rather be sitting at my desk. Onward and upward, I'm Digital Mermaid. I will see you next time for, hopefully that time will be the let's get everything up and running video. Bye.